introductory and overview kind of a topic, because I think that will be helpful for a wide range of audience. And also we'll touch a bit on Kubernetes as well, which is like one of the very hot topics in the industry today. Okay, so again, since we are not going deep technical, don't try and it's absolutely okay if you don't really understand how specifically certain things work. That is intentional, but I think the whole idea is to give you a bigger picture, which I think will be very useful in your journey in your careers. So yeah, so let's start it. Let me share my screen. I have a small deck. So this, sir, can
Yes, sure. I'll make you the presenter.
Okay.
So I had made you the presenter, Daniel. You can share your screen, your presentation.
Okay. Yeah. Okay. Can you all see my screen?
Yes, we can.
Okay, great. Okay, so yeah, we are talking about cloud computing today. So what exactly is cloud computing? Cloud computing is basically delivery of computing services over the internet. So when we talk about computing services, what are the computing services we are talking about? So assume that you're going to buy a computer, a PC or a laptop or anything of that sort. What would you be looking at? You would be looking at like the processor speed, the RAM capacity, the hard disk capacity, things like that, right? So these are essentially the computing services that we are talking about. So what cloud computing is basically delivery of all this through internet. So why do we need this? We need this because it can help us to innovate faster and to achieve something what we call as economies of scale. So economies of scale, it's okay if you don't know the term already, but what it means is optimizing our processes such that we are lowering the cost of production. Let's say we are making something in a factory. So there will be a lot of processes in a factory. It's basically like improving the processes so that we are able to lower the cost and increase production. So it's something like that. It comes from that industry, but we will actually see how it is, how we can, how we actually get that in the slides to come. So this is basically it. Basically, think of it like instead of, so if you want a computer, traditionally we go to a shop and buy it, but in the world of cloud, we basically go to a cloud provider portal and basically ask for a computer. But it's not actually a physical computer, but it's a virtual computer. You can call it as a virtual machine if you're already aware of it. So you are able to get a virtual machine over the internet, which you can use as a normal computer. And all the operations you will carry out through the internet. So that's the whole point. But let's see that with slightly more depth. So before we start all that, right, I need to, I think there's some prerequisites, especially you need to understand how a website works. So basically, I believe that a lot of people would have some knowledge around, the different protocols and different things involved when we talk about internet, but this is basically intended as like a starting overview for someone who's new to it. So I don't know how many of you have ever imagined, like whenever you type, whenever you open a browser and type something, type address, what happens? How do we get like the page, right? So, so what happens actually is, let's say you go in and type www.google.com. What happens is the google.com is basically a domain address. It gets translated to an IP address. So over the internet, when you're connected to the internet is part of, it's a huge setup, right? It's network of computers all around the world. So what happens is there are some DNS providers who have a table. Think of it like simply a table where they would have like for www.google.com, the value is 74.125.68.113. Again, I'm simplifying a lot of things, but this is essentially it, right? So if you, instead of that, if you go for www.yahoo.com, they will have a different mapping to a different IP address, right? So what this DNS service providers would do is whenever we send them a request about the like the domain, we would get a IP address, something like this, right? And all this happens transparently. The browsers are actually doing this. We don't do this physically, but the browsers are actually coded to do all this, and that's why we don't see this. But it's very fast, and we don't even know that all this is happening. But I'll not get into the mechanics of that. But yeah, so we finally get an IP address, right? So with that IP address, what happens is our browser initiates a HTTP request. So the HTTP request, HTTP is built over the TCP IP protocol. Some of you might have studied about it. So basically, it's a protocol that can work reliably over the internet, even though internet is like a very kind of an unstable network because it's a network of computers all around the world. It's not very stable, but TCP provides you that that reliability over the communication by ensuring that you get like the data integrity and everything. I'm not going to go into the details, but remember this: the browser is able to use the IP address that it got to basically send the request. So ultimately, what happens is this request travels over the internet, and it finally ends in a server. So imagine this is like a Google server, and the Google server gets the request, and Google has been coded like it has lots of applications running in its servers to basically fulfill our request. So it knows that we are asking for the search engine homepage, and basically it gives us the can you hear me? I think someone muted me. So
We can hear you, Moses. You can continue.
okay, thanks. So yeah, so basically Google responds with HTML, CSS, and JavaScript. Think of it like code that the browsers understand. You don't have to understand, but basically, some of you might already know that how HTML works and everything. Basically, all that is required by our browser to show whatever we see in the website, right? That is how basically a website works. So having said that, let's basically see here. We see a server here, but actually, what is a server? It's the same thing that we talked about earlier. A server is basically like a computer that we buy. It has processor, it has RAM, it has storage like hard disk. It has like networking capability so that it can communicate with the outside world. And it's all layered by an operating system that handles all the tasks and like manages all the applications that are running inside it. So this server is basically what has the programs that running to serve our pages. So in Google's web server, there will be a program running which can get the request for google.com, and it can respond with the HTML and other stuff that we saw earlier. So now, again, I'm simplifying a lot of this, but one thing we need to understand is whether one server is sufficient or not. So is one server machine enough? Obviously, as when the requests are few, that is like when there are only a few people, maybe 10 people, 20 people accessing a simple website, then the server is able to respond without any performance issues. But like any computer, right? So if you run a lot of programs in your own computer or a laptop, what happens is the performance will start degrading, right? Because some of you might know that the processors would basically, divide the processing capacity to different processes that are running in your machine, and ultimately each of that only gets a share of the processor. So when you have a lot of programs running, each program's performance would start to basically suffer, right? Same thing happens in a web server also. The more the number of requests, right, it starts to, becoming slow. And finally, when you have lots of users, like I'm talking about Google scale, it's impossible for like one or a few of the servers to handle all the requests that we are talking about. So what happens in the case, like finally, the server would start, responding slowly, and finally it might even crash. So ultimately, the service would not be working. So keep this in mind. So as the number of users increase, we need more computing capacity or more servers, and this is something we need to keep in mind. So otherwise, we will end up in a situation like this. Right? I mean, it's just intended as a funny slide, but yeah. So crash isn't, we are not talking about this sort of crash. We are talking about like applications not responding. Yeah. So okay. So in the case, right? So how do we handle high traffic, right? We need to be able to handle high traffic. Otherwise, our business will suffer, or we will not be of any use, right? So what happens is typically these corporations, big corporations who have a lot of clients or customers visiting their websites, they have like a huge setup on their site, right? So they have multiple servers. So if you can see here, they have like multiple servers, each running the programs that we talk about. So if that is the case, right, how does the request go? Because the request, we only have one IP address, right? If you remember, we have one IP address that needs to go from our browser and needs to be handled, right? And some of you who know networks would know that the IP address is like an address for every machine, right? So how do we handle that? So there is like a very simple pattern. It's called the load balancer. So load balancer is, think of it as a computer which can basically get the request, and it can divide the request to different servers inside the cluster or data center, basically. So basically we have some computer in the front sitting and receiving all the requests and basically sending it to different computers behind, and basically relaying, acting like a relay machine, right? So this way we are able to keep increasing the number of servers, and only our load balancer needs to know, and we can still use one IP address which would finally resolve to the load balancer, and the load balancer would know how to handle the request. So this is how it works. So remember this. This is pretty important for us to understand, like anything related to internet or cloud or anything of that sort. So remember this, as the traffic increases, you need more computing resources, servers, and also another thing you need to understand is low traffic. Let's say you have low traffic, but you have so many servers sitting in your data center or anything. What happens? Basically, you're underutilizing, right? So let's say you buy a huge computer, like very expensive computer or a laptop, but all that you do is basically browse a few websites. Then you're actually underutilizing the machine. So similar to that, you can have so many servers, load balanced and all that. But if your server, the requests are not that many, basically you're wasting money, wasting resources, energy, everything, right? So keep these two things in mind. It's pretty important for us to be able to understand the rest of the the session. So let me take you on a journey. Maybe imagine we are going to 25 years before. So assume that why 25 years? Because think of it like a age where internet was not popular, right? So assume that you want to become a bookseller, right? Maybe you want to sell books, and we will see how what are the options for you to sell, right? So put yourself in that shoes and think like, how would you sell books, right? So different ways you can sell books, right? So maybe you can build a shop. Uh, I want to sell books, but why do you want to build a shop? So, but this is one of the options, right? So you can go, find a land to buy, and then you can build a shop, and then you can try selling books, right? This is one option to sell books, right? Uh, Maybe another option which we all probably would think is renting a shop, right? So you will basically find a place and maybe rent a shop, maybe a small shop or big shop as per our need, what we think is, what we need, and then we will sell books, right? So this is one option. Another option is, why not just rent a small book stand in a grocery shop? Some of the grocery or like the departmental shops or the supermarkets, they offer you this option. Basically, you can set like a small, you can basically rent a small stand and you can sell your stuff. So this is also one way, right? Again, think of this as just an analogy, an example. I want to relate to cloud computing later, but think of this like, so we saw three options, right? Option one is like building a shop, basically buying a land, building a shop, and then sell books. And then this is a slightly cheaper option, I would say, which is basically renting a shop and then sell books. Another is, slightly probably the cheapest of all, just rent a small place and then sell books. Again, there is pros and cons to each of that, right? So one problem with this building a shop is you build a big shop and finally you don't have much customers. Basically, you have wasted a lot of money. You have bought a land for selling books, and then you build a shop to sell books, and then you don't have customers. So what happens is basically it's not very good, right? So from a business perspective, it's a disaster, right? So that's why most people don't do this in a traditional sense. But we will see how cloud computing is related to this later. But remember that each of this has pros and cons. So there are some advantages to it, like when you can store books as many as you want, as long as time you want. Nobody is going to ask you for any permissions, or you don't need to do anything. So it's easier that way, but cost is huge, right? So the next option is to rent a shop. right? This one is probably the better option. You rent a small shop first, and then you see, uh, if you have more customers, then you can probably sell a lot of books, right? This is the cheapest option. But having said that, this also has pros and cons. So if your business is not doing well, then it's pretty easy to shut down the business. You don't even have to pay the rent or anything of that sort. You can terminate or whatever. You can say, I don't need the shelf anymore or the stand anymore, and then you can easily come out of that, right? So think of this and imagine that there is the semester exams next week. Not for you guys, but for those who are living in 1995. Yes, okay. So what happens? You have like lots of students lining up before bookshops to buy books, right? So basically what I'm trying to show you here is basically a surge in demand, right? Suddenly you have like a lot of people wanting to buy books, and what can handle this surge faster? Which of the three options can handle this surge faster, right? So we talked about three options. Again, each has pros and cons. So, but imagine this: if there is a lot of search, and suddenly you think that okay, you will have more people coming in. Maybe if you had bought if you had just rented a stand, then you can ask the grocery shop or the departmental store to give you more stands. You can rent more stands, and then you can have more books, right? There's one option. Again, it's all just analogy. So not exactly how it relates to computing, but yeah. But yeah, let's come back to the normal time now, and imagine this. So we were talking about number of users, number of people wanting to buy books. So you can think of that. Can you relate to this problem now? So we have the same issues we talked about. We have a lot of maybe sometimes you think that you need a lot of uh, you will have a lot of customers, and then you buy you basically build a big shop, but then you don't have customers, then you're at a loss. So another option is you think you want to try out a little first, so you buy a small stand in a shop, and then if you have more customers, then you can rent more stalls, right? So this is exactly how cloud computing came into the picture, right? So here, one of the chief tenets of the third option that we talked about is basically we are renting a small space in a shop that sells other things also, right? Maybe chocolates, medicines, or whatever, right? So that core thing is sharing, because in that case you can easily change to the demand, right? Maybe uh, when you have a lot of shops, maybe some businesses won't do well in certain periods of time, and those people can reduce the number of the area that they take, and maybe some other businesses which have high demand can actually maybe think of like Diwali time or something, right? You will have a lot of shops selling crackers, right? But after that period, nobody will buy crackers. So basically, this is in adjusting to that demand, right? So this is exactly what cloud computing made possible. Uh, Again, before 15 years, nobody thought of this, or like maybe before 20 years, nobody thought of this. Before 15 years, some people started thinking about it. But basically, uh, you would be surprised. But what a lot of people were doing is basically they were to sell books. A lot of people were actually building or buying their own land and actually building a shop. This made sense 25 years back, but if you think about it now in the field of computing, it doesn't make sense anymore. But if we relate to the bookshop example, we can see that it is not a very wise idea, right? So that is what cloud computing tried to solve. So what it did is basically made sharing possible. So if it is a physical computer that we have on our on our table, right? It's not possible for us to share it with like someone from outside, right? So what this cloud computing companies did is they started building data centers, huge data centers like this. So what the picture that you see here is actually a data center photo, and these cloud providers. So when I say cloud providers, we are talking about people like Amazon Web Services, AWS, Google Cloud Provider, GCP, or Azure, which is like a Microsoft cloud solution. So these companies started to build huge data centers, right? And they built something on top of all this, right? So they built these data centers all across the world, right? So in different regions, maybe a few in the US, few in Asia, few in different parts of the world, and they also invested heavily by basically ensuring that all of these regions across the globe have like really fast internet connectivity by huge fiber optic cables that are going under the sea and other things. So they made like the networking and everything like really fast across these data centers. And what they did is they created a layer of virtualization, right? So here what we talk about in the photo, what you see is actually, think of it like hundreds or thousands of computers, storage, and things like that. It has networking capability, and basically that's the hardware, that's the layer below that we are talking about. So they built all this, and then they built another layer on top of it, virtualization layer, which allowed all these hardwares, right, to all this hardware to be shared among multiple people. If it was a single computer, it was not possible to share. But what they did is, in a single computer, they ensured that you can run multiple virtual machines, right? Some of you might already be using virtual machines, so it's the same virtual machine that we are talking about. So basically, they virtualized all the components, including like the processor, the disks, the storage, the networking, and everything, and provided a way, right, through different means. What I have listed here is just a web portal. Maybe if there's time, we will even like look into it by seeing a demo of it. So they built all this and provided an easy means for anyone like you and me to be able to use their resources. So what this suddenly meant is company 1, company 2, company 3, the ones listed here, can actually start using these resources, right? So they don't have to build their own data centers. They can just start using whatever is already built, right? So this also helps them to achieve lower costs, right? If we were to build, maybe we have to employ a lot of people. We have to manage all the infrastructure and do it, right? So if each company, 1, company 2, company 3 had to do it, they probably had to have maybe 100 people managing this. But if it is all done under one simple, or not simple, but if it was all provided by one company, right, then maybe they can just employ 50 people or 40 people. So this is the cost cutting or economy advantage that they are able to reap. So this they are able to pass to the companies. So that means that company 1, if they were to build their own data center, it will be much expensive than to actually hire or basically rent some of these virtual components. And outside of all this, there is also another nice feature out of this. If company 1 had to buy or build the data centers themselves, they will have to basically spend all the money upfront, right? So either through loans or whatever mechanism, but ultimately they will actually be spending a lot initially, right? But then the benefits they will only get slowly as the number of customers increase and whatever as the business grows or whatever. But initially they'll have to spend for all this infrastructure. What this cloud providers did is they came up with like a nice pricing model where you can hire basically it's called pay as you go. So if you use this much for a month, then you are billed accordingly. If you use a lot, you are billed more. So it's more like phone usage that we do. Like if we use phone a lot of internet and other things, then basically we pay a lot when we have a postpaid connection, right? So similar to that. So they came up with this model. So it was very advantage. It was a lot. It was very easy for these companies because they don't have to spend money in the beginning, and they can actually get the money from the business and actually spend for this infrastructure. So all these made cloud very successful, and all the companies, instead of building their own data centers and developing and deploying their applications and websites, they started using cloud. So cloud has been adopted right from 2010 very widely. So that is why we are looking at it now. So this is basically the why we are looking at cloud computing, right? So here there is a word infrastructure as a service. So we already talked about computing, right? So some of the core things in a computer is like the processor, storage, and the memory, right? Networking, right? So these things are actually called infrastructure, and this is provided as a service, right? So this is called infrastructure as a service. It's a very commonly used term in the industry, IaaS, basically infrastructure as a service. So this is what it is all about. There are also other models that cloud providers eventually came up with. So one example is, okay, so we talked about infrastructure as you go. Infrastructure as a service. We talked about pay as you go model, and the different providers are like the AWS, one of the pioneers, Azure, Google Cloud. These are all the companies providing it. Then there is also another innovation that they came out with is like platform as a service, right? So what it means is, I'll try to keep it very minimal here. Basically, it's basically think of it as another layer of abstraction above the infrastructure that we talked about. So you have the VMs, virtual machines, virtual storage, virtual networks, right? So above that, imagine there is another layer which makes it even easier for you. So all that you need is a runtime to run your application, right? So they provide this runtime without even us having to actually worry about the VMs or anything. So think of it as another layer of abstraction that hides everything, just provides us an easy way to deploy an application. I will actually show you this if we have some time. So basically, this is called platform as a service because we only see what we basically we only use like what we need, even without worrying about the virtual resources that we talked about. Now both of these are very popular. A lot of companies prefer infrastructure as a service because that gives them like a complete control of all the virtual resources, similar to like having control in a data center. You instead of physical service, you only have virtual service, but it gives you good control of the virtual server. So this is basically the different sharing models. And maybe you've heard of SaaS before, right? It's a very popular keyword again. What it means is software as a service, slightly different from IaaS and the platform as a service. What this is basically is like, let's say today we are seeing this here, right? We are using Microsoft Teams, right? What if everyone who wanted to do this video conferencing had to build their own application? Then every institution in the world, because now we are all mostly working remotely and like learning remotely, it's not even possible to for every company to invest a lot of money to build softwares like this, right? Because it takes a lot of effort and money to come up with a software like Teams or Zoom or anything of that sort. So what these companies do is actually build one solution that can fit different use cases, right? So basically it's pre-built applications which can be slightly configured depending on the needs. And basically it can be used by a lot of companies. So those companies don't have to actually build these services. So to give you a analogy in the real world, maybe if you are a bookseller, but now imagine you're a you want to go internet and you want to sell your books over the internet. So one thing you can do is you can build a website to sell your books. But another easier option is basically sell it on Amazon or sell it via, I mean, in Amazon, you can register as a seller and you can sell, or there is another platform called Shopify where you can easily create a store application for you without having to actually do all the coding and development. So this ability is called software as a service, right? So again, I haven't covered a lot in depth, I would say, but this is like I think covers most of it. Now let's have a quick demo. I think we have like about 12 minutes remaining. Let's have a quick demo. So I'm on Microsoft Azure site. Can you see the screen? Can one of you confirm? Maybe Sudhir sir, can you confirm that you are able to see a blue screen?
Yes, we can see. Yes, we can see.
Thank you. All right. So I'm just logging in. I just created an account, and most of this has like a free usage tier, basically to try out it. So I think they give $200 of resource that you can actually create and use to try it out. So I'm going to create a platform as a service. So here you see there is virtual machines, there are storages, there are different other software components actually you can create easily, right? But I'll not create a virtual machine because it takes a long time to configure like a machine. You need to store, select a lot of aspects. So this is a PaaS offering, platform as a service offering, which gives you just the runtime to deploy your services, right? So I'm going to just create a simple, service and show you how easy it is. I don't know, like, I don't know how many of you know HTML, but I think it's pretty easy. So basically, if this is a web page that you're seeing, right, the source code for this is like this. It's pretty simple. All that you have like tags to say what it is, and then this is the HTML that we talked about. Browsers know how to display it. So here, this is like a heading, and this is also another heading. So it appears bigger, and this one is slightly smaller because it's a smaller heading. So again, I'm not getting into the details. Most people would know this. So I'm skipping this, but imagine this is just an application that we want to deploy, right? It's a very simple application, but here we're not talking about applications. Like if we have to deploy Google application, it will be massive, right? We're not talking about it, but just to give you a sense of what this. So I'm just creating some of the prerequisites. Resource group is just like a grouping of all the virtual resources we create. So here I'm going to create a web app. So it's a application that I'm going to create. Basically, it gives us like some compute and other things. You can actually see here, it gives you 3.5 GB memory, and this is like a processor, how much processor we are actually using. You can change if you want. If you think you need a bigger one, you can change the size. But for us, this is enough. So I'm going to just say maybe hello world or something. Okay, I need to find a unique name. So seems to be a unique name. You'll know why I have to find a unique name later. So let's go. So I'm not going to worry about the remaining options because okay, maybe I should select something else. Okay, so though we are just going to deploy a HTML application, it asks for what is the runtime. I'm not actually using a runtime, so we can actually select anything, but PHP works for us. So yeah. So basically, I've clicked create. I've filled in a simple form. Stuff to run the application. I'm not even building virtual networks. I'm not building any virtual machines. That's because I'm using a more simplified version of cloud offering, which is the platform as a service. If I were to use infrastructure as a service, I would actually be doing all this. I would be creating like a virtual computer, and then I will set networking rules and other things to ensure that nobody can hack into our the servers. So I'm not doing all that. That's because I'm using a simplified abstraction just for the sake of the demo. Right? So it's taking some time to deploy. Let's wait for the deployment to complete. Okay, so our deployment is completed. So I'm going to just find out how to deploy an application to this. So one method is like actually copying files directly through FTP. FTP is a protocol which allows you to copy files via internet. So I'm just copying the stuff from here and adding it here. I have to accept some certificate, which is all part of the FTP communication. So there is already some page, default page that they provided. I'm going to delete it. So I'm going to just delete it. But this is our application directory. So this is the HTML file that I showed you earlier, which had the this simple application. Now imagine you can see that this is in my computer, in my C drive or whatever.
Hey.
Now I'm going to basically send this file, upload it here. So I've transferred the files via FTP protocol using this tool called FileZilla. I don't have to worry about it, but you can see that the file that we have here is now sent here, right? So it's as simple as that. Now we have deployed our application into actually the cloud, and it is accessible for everyone, all of you actually. This is the URL of this website. This is not fancy google.com, but actually you can see that it already works. So now think of this. If I had to deploy this application, if I had to build my own data center for this, and if I had to have all the servers and all the other thing, imagine how much time, money, and effort it would have cost. But you see this, it's as simple as like a 5 minutes task. So this is the power of cloud that we are talking about. If you don't take anything from it, but at least this I think would be pretty obvious for you, like ease of use and the cost. So I didn't pay anything for this. If people use our websites, maybe I'll have to scale the application. You can actually see that I can scale up, scale out. Scale up is basically adding more RAM into one machine, more RAM, more processor, and other things into one machine. Scaling out is basically the load balancer thing that we talked about. You can actually, right now it runs in one computer. I can make it to run 20 computers if I need, right? So all this is going to cost money, not now, but end of the month or whatever, when actually the bill comes in, I will pay how much I use, right? So now if I know I only need like a few customers would be coming and visiting my website, then I can only provision just one or two, right? If a lot of people are going to visit my website because it's becoming famous, then I'm probably doing more business, and then I can actually use 20 or 40 or 500, right? Depends. So this gives us the flexibility, right? But again, I think, yeah. So this demo is complete. So let's go back to our slides. It's pretty simple now. It's good. It's all working, but there are other problems also, right? One problem is constant tune-up is required. If you want to optimize the cost, you have to find out what is your day-to-day usage, and then you have to you have to adjust your computing accordingly. So if you need 2 servers or 50 servers, you have to adjust all that, like how I adjusted earlier, right? So this has some downsides, right? You need to constantly watch, and you need to adjust. It's much easier on the cloud. You don't have to buy new physical servers and install it in your data center. If you had to do that, it will take 3 months to increase, the capacity. But here, it's a click of a button. But at least it's just a click of a button, right? But you still need to do the click. You have to find out, and you need to do it. So this can is there a better way? That's something that we will see, right? So another thing is all this VMs and other things, right? So I didn't create a VM here, but we could have actually created VMs and deployed our applications to it, and then we could be actually increasing VMs sizes and other things. And VMs, like other computers, right? They all have operating systems and other things which are bound to fail. Sometimes these operating systems will even if you're running the application, it can fail for many reasons, and then you will actually start to have like lower capacity, right? So at the time, what will you do? You have to have someone looking at all the statistics, the metrics and other things, and then you have to go and fix it, or you have to create a new VM and then deploy the application and load balance it and run it. So it's all more work. Basically, you need someone to watch it and fix that, right? Another issue is now I've used Microsoft Azure. It gives you an abstraction. So the app service that we talked about earlier. This is a Microsoft Azure offering. It is not available in AWS, or it is not available in Google Cloud Provider. They have equivalents, but it is like buying different TVs from different people, right? There are differences, and our application sometimes, if we have to automate the deployment and other things, it is hard because you have to use different APIs to upload and other things. So maybe AWS, this FileZilla won't be allowed to upload. Just an example. So what will you do? Would it be better combine interface, one way to do everything. This brings us to what I would say as Kubernetes. So Kubernetes is basically a cluster manager or an orchestrator. So what it does is basically, now we only deployed one application and ran it in one virtual machine, or not even virtual machine, it abstracts out, but we could actually build a application and run it on one VM. We can also have many VMs and then run it as okay, sorry, I think I'm not sharing the screen. Okay, so we can have like many applications running in one VM or one application running in many VMs. All configurations are possible, but you need someone to manually go and assign and other things that I discussed, right? All the three problems. So Kubernetes solves all these three problems. So it is like, think of it as like a manager doing all this, but just that the manager is actually a form of software. So basically what it does is how it works is basically, after we need to set up a Kubernetes cluster. There are multiple ways to set up the Kubernetes cluster, but we are not going to the details. But all the platforms provide a way to create a Kubernetes cluster, be it Google, Microsoft, or AWS. And what you can do is instruct Kubernetes to run our applications through code. You say that I want 3 instances of this application running, and if it exceeds certain resources, you should use more resources. Basically, you can say increase it to 20, increase it to 40. You can instruct it basically, and once you have done that, Kubernetes will start doing everything. So it will actually start managing everything for you. It will basically, if one computer goes down, it will actually even has a capacity to spin a new computer automatically, provided you have configured everything. So it's like one configuration, and then you are able to actually get everything running without, or basically with less people, and nobody needs to watch. And then when there are more users visiting our websites, we don't have to manually go and increase the servers. Kubernetes can do it all by default. So this is basically a very short introduction to Kubernetes. And in the interest of time, and basically this is what I planned as well. So we're at the end, and I think we're just in time. So I'll open up to like questions or anything, like maybe 1 or 2 minutes if we have time, and then I think we can end the session.
Thank you, Daniel. It was an excellent presentation about cloud computing, and the demo part was top-notch. And as Daniel told, let us open this session for the audience for any queries. Yeah, students, you can ask your queries.
Okay, maybe if you have any messages in the chat, then yeah. Okay, here.
Good morning, Daniel. I'm Dr. Usha Banu. I have joined last 5 years before, and your presentation is very good. You have given a very clear presentation and demo. And as a research point of view, I have basically 2 doubts. Shall I ask the question, please?
Yeah, please go ahead.
Since everyone are producing data and also consuming data, everyone, even a layman is now using YouTube, everything, okay, and we are producing big amount of data, that is big data is there. So where this filtering algorithms can be deployed in either with respect to that of the servers or in the interfaces. That is what is we need to filter the data, big data analytics, and some filtering algorithms has to be implemented when it comes to the end user. Yes. So where it can be implemented?
Okay, so again, if you're talking about like huge services like YouTube and other things, right?
Yes.
If you are talking about what recommendation videos that we get, it is tailored to each user. They do a lot of analysis behind. They have great algorithms running, analyzing all the data, behavior patterns, our what even what emails we get, what search we do, because it's all Google's products, even YouTube. So each company has their own solution around that. So each company has like a big data team analyzing the data and have algorithms which can actually find out what they want, and they are able to do filtering, basically all ETL. It's called extract, transform, load. They're able to do it, and they're able to basically get some business insights out of that.
Yes.
Is this?
Yes,
I mean,
I'm just want to confirm you whether it is feasible to have that Kubernetes that will also take care of this solutions, because it's a big problem we face when we have this thing. It is also the Kubernetes is also basic. We can provide that solution with that itself. I
yeah.
just want to know.
So Kubernetes is pure infrastructure stuff. So
Yeah.
whatever is running, right, whatever is running in the computers, it can be anything. It can be a simple web application that I deployed. It can be a huge complex machine learning processing
Yes.
that can work. Kubernetes ensures that you tell Kubernetes how you want to run the application, how many instances of the application you want to run, so that you can load balance and everything. You tell that, and Kubernetes will do that. Kubernetes can
Yes.
work on any workloads, right? But
Yes.
having said that, uh, if you want to do this, right, there might be some past services already.
Yes.
Like maybe if you're talking about Azure, we have like big data services as well. Um, so you have Hadoop clusters and things like that, which are basically meant to do this or solve this problem better. Or so as I told you, the application that I deployed, I could have created Kubernetes cluster and deployed it, but I did it using an app service, which is a
Yes.
platform as a service. So you also have other platform as a service that you can make use of for your big data analytics purposes. Or you can also use Kubernetes. It depends, right? Each of them has pros and cons. So you have to go back to the analogy that I told you. Uh,
Yes.
you can build a shop. If you think
Uh,
your business is going to grow, so you can do that. You can acquire more land, build your own data
yes.
center. Yeah, it all depends. I think the insight is you should start small. So that's why the past services come in. And then if you think there is a real need to go, slightly deeper, have more control, then you can start looking at infrastructure as a service and Kubernetes kinds of in the middle of infrastructure as a service and as the platform as a service. Yeah,
Yes.
but it's
Yes.
possible.
Yes. Thank you, Daniel. Thank you for your explanation. Thank you. And one more question. I just want to know whether all the services end user is enjoying, it is based on edge computing, I think. Edge computing only, till your infrastructure and service management, it is cloud part, and when we use at the end, it is edge computing, or it is what we are actually doing. I just want to know, Pa.
Yeah. So right now, when you saw when I did the demo, I just deployed a simple application in one region, which is the US central region. It's basically one of the data centers in US, right? So if I have a high demand application, and if I want to deploy it all around the world, so that everyone can access it fast all across the world, not just from the US or India for that matter. If you have to do it everywhere, then you have to spread the machines all across the world. So if we have to build data centers all across the world, it's not possible, right? It will be huge
Yes.
money, right? So cloud computing allows you. Basically, there is some content distribution networks. Uh,
Yes.
as I type in. So there are ways to build a content delivery network. which will basically takes the data closer to the viewer's point. So when you start using those services, you're actually using a practical implementation of edge computing.
Yes. Okay.
Yeah.
Thank you. Thank you so much for your explanation, and all the very best for your future endeavors. Okay. Thank you. Thank you for being with us, Mo.
Any other queries? Yes. Any other queries from students or staffs?
Okay. Daniel, how are you?
Good, sir.
Okay.
Yeah.
Okay. Very
How are
nice
you?
presentation. Okay. Completely switcher from that is called electronics communication to computer science. Okay. Actually, you are very good, strong fundamentals in DSP and image processing. Okay. Okay. Are you remember that UG project?
Yes, sir. Yeah.
Yeah. Yeah. Okay.
Content-based image retrieval.
Yeah. Very good.
Yeah, image processing.
Very nice.
Yeah,
Okay.
but
Okay. Let me know. That is, you told about the task services. What type of task services are doing? In any RTOS based or any?
sorry, sir, I didn't hear your question.
That is task services. No. That is, for example, multitasking services. What type of services are doing?
Yeah. So multitasking. I mean, like all this. All the services, right, can actually run parallelly. Whether they are running in one server or across many servers, they are actually running parallelly. But for application to work parallelly, there are some fundamental things we need to do when we build applications.
Okay.
So talking about image processing and media services, right? So there are actually a lot of image processing and other services also, like maybe, yeah, I think they're all grouped under media services. But yeah, again, the same algorithms, but instead of running it in digital signal processor or anything, it's implemented in code, but it's the same algorithms, the image retrieval algorithms and other things.
Okay.
Yeah, so we can use this as well.
Okay. Okay. Thank you. Thank you. Okay.
Yes, sir.
Okay.
Okay. Thank you, sir. And so we shall complete this meeting. So Preeti ma'am will give us the vote of thanks.
Yes, sir. Thank you, Sudhir, sir. So I would first like to thank management, principal and vice principal, sir, for giving this opportunity to conduct the expert lecture on cloud computing with Kubernetes. Further, I would like to thank our HOD ma'am for giving us chance to organize this event. I would also like to thank Mr. Daniel Moses for accepting and giving a wonderful presentation and also excellent demo session for our students and staff and clearing all the doubts. I would also like to thank my co-organizer, Mr. TV Sudhir, for his endless support. Thank you all.
So nice presentation, Daniel.
Thank you, ma'am.
Okay, and I have taught this computer networks and then communication networks. So I think I don't know whether this is the answer for Uday Kumar's doubt. Actually, TCP will have various queues before the information reaches the application layer. So the
Yeah.
queues will be depending on the header information available in the content of that UDP. So UDP will segregate it and it will send according to the queues. So the queue will be respectively linked to the respective application processes in the application layer. So that is this is how we have taught this particular aspect. I don't know whether this is the way it reaches the various applications.
Yeah. So, I mean, generally on a day-to-day basis, all this is abstracted, in different servers, like there is a web server, for example. The web server is basically is something that's running in the layer 7 or the application layer, I would say. So it is able to work with the operating system, which takes care of some of the other underneath layers, like layer 2, 3, and other things. And basically the some, if you're talking about security TLS kind of encryptions, the web server is also able to handle that. So when generally on a day-to-day basis, until and unless we are working for those web server companies, right, like Nginx or Microsoft IAS kind of, until and unless we are working for those companies, when we are just normally building applications, we generally don't have to worry about it. So all that we need to do is basically expose some roots. Basically, roots are like just like file path in a normal file system. We just need to expose that to the web server, and the web server will handle all the underneath part, like the communication, how it comes, and it will only basically. So we'll be working only on the layer 7. But yes, what you're saying is very true. For people who are implementing the web server software, they will have to understand all the different layers, including how to handle different protocols and other things.
Thank you, Daniel.
Thanks, man.
All the best.
Thank you.
Okay.
Thank you, Daniel.
Thanks,
I am proud of you. Okay. You are my best students. Okay. You are my okay. I think I did project that is based on wavelet transform. Still, I remember. Okay, that is 3 of you, no? Like what other guys are doing? That is your batchmate.
They are in different industries. Some of them are working on like electronics field as well. Like 1 or 2 working in Intel and then Bosch and other things. But yeah, again, today I think everything is converging. So understanding the fundamentals is very helpful whatever we are working on. For example, I was purely working on software
Yes.
in the initial years.
You are completely changed, no?
Yeah, but I still feel that I started working on the cloud and other things for the last two years, predominantly on cloud and DevOps related work. But there I could actually see a lot of what I learned in bachelor's, like the protocols, especially around communication and other things. Yeah.
Okay, nice. Okay, and also I need your contact numbers and also from your friends also. Okay, because it's very easy to organize seminars, expert lecture like that. Okay, for benefit of the current students. Okay?
Sure, sir. Yeah, I'll encourage them.
Okay, I think your Facebook communication is lost. This is what is happened? Facebook communication.
Actually, you can message me on Facebook. Still should be able to message me on Facebook, I think. Yeah. Yeah, I think I disable.
Okay.
Sometimes I do it.
Yes. Okay.
But my messaging messenger would be working always.
Yeah. Okay. Nice. Thank you, Daniel. Thank you. I still remember that is we went to North India tour. Tannokumar Namagar Kasa Subhashini ma'am. He creates a trouble. No, Adipati seri ma'am. Namagar ka.
ஞாபகம் இருக்கு சார்.
ஹாஸ்பிடல் கூட்டி
அதெல்லாம் ரமேஷ் சார் கிட்ட அன்னைக்கு சொன்னேன். அந்த நம்ம குளுமணாலில அந்த ஸ்னோல போட்டோ எடுத்து.
ஐயோ.
Yeah, I still have that.
ஆமா. அடிபட்டு வர.
Daniel.
Yeah, but it was very good time, sir.
Yes.
Yeah.
But I was saying, it is because of you we were comfortable. நீ மட்டும் டென்ஷன் ஆயிருந்தா நாங்களும் கொஞ்சம்
ஆமா
restless ஆயிருப்போம்.
ஈ ஸ்கூல் ஒன்லி நம்ம அவன் ஃபுல்லா தான் இருக்கான். நம்ம தான் வந்துட்டோம்.
Well, actually, it was not much like pain and illa, but yeah. So I think it's all
Sir?
happens.
Okay. Okay, then. Thank you.
Yeah, thank you, sir. Yeah, maybe if things go, I mean, like if things improve, and if when I come to Chennai, maybe as part of some alumni get together or whatever,
Sure.
love to meet you all, meet all of you.
Okay, thank you.
Thank you so much, Daniel. Thank you so much.
Thanks, everyone. Yeah. Bye.
Thank you. Yeah.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, Sridhar. Thank you,
Thank
Preeti,
you.
ma'am. Thank
Thank
you,
you.
HOD, ma'am, for organizing.
Thank you,
Thank you.
Daniel.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.